Section 1. Forces shaping the Earth. Inside the Earth. The ground feels solid when you walk on it and downright hard if you should happen to fall. Yet Earth is not a large rock, solid through the middle. Beneath our planet's solid shell lies a center that is partly liquid. As Figure 1 shows, the Earth has different layers, much like a melon or a baseball. At the center of the Earth is a dense solid core of hot iron mixed with other metals and rock. The inner core lies about 3,200 miles, 5,150 kilometers, below the surface. Scientists think it is made up of iron and nickel. They also believe the inner core is under tremendous pressure. The next layer, the outer core, is so hot that the metal has melted into a liquid. The temperature in the outer core can reach an incredible 8,500 degrees Fahrenheit, about 4,700 degrees centigrade. Surrounding the core is the mantle, a layer of hot, dense rock about 1,770 miles, 2,850 kilometers, thick. Like the core, the mantle has two parts. The section nearest the core is solid. The rock in the outer mantle, however, can be moved, shaped, and even melted. If you have seen photographs of an active volcano, then you have seen this melted rock called magma. It flows to the surface during a volcanic eruption. Once it reaches the surface, magma is called lava. This movement of the matter in the mantle releases much of the energy generated in the Earth's interior. Earth's upper layer is the crust, a thin rocky shell that forms the surface. It reaches only 31 to 62 miles, 50 to 100 kilometers deep. The crust includes ocean floors and 7 large land areas known as continents. The continents are North America, South America, Europe, Asia, Africa, Australia, and Antarctica. The crust is just a few miles thick on the ocean floor, but it is much thicker below the continents. Shaping the Earth's surface. The Earth's crust is not a fixed layer. It changes over time as new landforms are created and existing ones change forms. For hundreds of millions of years, the Earth's surface has been in constant motion, slowly transforming. Old mountains are worn down, while new mountains grow taller. Even the continents move. Plate movements. The theory of plate tectonics explains how the continents were formed and why they move. As Figure 2 shows, each continent sits on one or more large bases called plates. As these plates move, the continents on top of them move. This movement is called continental drift. The rate of movement varies from just under 1 inch, 2.3 centimeters, to 7 inches, 17 centimeters, per year. This movement is too slow for people to notice, but over millions of years, it can have dramatic effects. Look at a map of the world. If you think of the eastern coast of South America as a giant puzzle piece, you will see that it seems to fit into the western coast of Africa. This is because these two continents were once joined together in a gigantic landmass that scientists called Pangaea. About 200 million years ago, however, the continents began to break and move apart because of tectonic activity. When plates meet. The movements of Earth's plates have actually shaped the surface of the Earth. Sometimes the plates pull away from each other. Plates usually pull apart in ocean areas, but this kind of plate activity also occurs in land areas, such as Iceland and East Africa. Plates can also collide. When two continental plates collide, they push against each other with tremendous force. This causes the land along the line where the plates meet to rise and form mountains. The Himalaya mountain ranges of Asia, the highest on Earth, were formed from such a collision. Collisions of continental and oceanic plates produce a different result. The thinner ocean plate slides underneath the thicker continental plate. The downward force of the lower plate causes magma to build up. Then the magma erupts and slowly hardens, forming volcanic mountains. This is how the Andes of South America were created. Earthquakes are sudden and violent movements of the Earth's crust. They are common in areas where the collision of ocean and continental plates makes the Earth's crust unstable. For example, so many earthquakes and volcanoes occur around the edge of the Pacific Ocean that people call this region the Ring of Fire. Sometimes two plates do not meet head-on, but move alongside each other. This movement makes cracks in the Earth's crust called faults. Movements along faults do not take place constantly, but occur in sudden bursts that cause earthquakes. One of the most well-known faults in the United States is California's San Andreas Fault. A number of very destructive earthquakes have occurred in the region, and the threat of more still exists. Weathering. The movement of tectonic plates causes volcanoes and earthquakes to change the Earth's landforms. Once created, however, these landforms will continue to change because of other forces that work on the Earth's surface. One of these forces is called weathering. Weathering is when water and ice, chemicals, and even plants break rocks apart into smaller pieces. For example, water can run into cracks of rocks, freeze, and then expand. These actions can split the rock. Chemicals, too, cause weathering when acids in air pollution mix with rain and fall back to Earth. The chemicals eat away rock and stone surfaces. Erosion. Water, wind, and ice can move away weathered rock in a process called erosion. Rivers, streams, and even rainwater can cut through mountains and hills. Ocean waves can wear away coastal rocks. Wind can scatter loose bits of rock, which often rub against and wear down larger rocks. In cold areas, giant, slow-moving masses of ice called glaciers form where water accumulates. When glaciers move, they carry rocks that can wear down mountains and carve out valleys.